Okay, in the previous video, we discussed about the formation of the dark and bright rings. So here we are going to derive the general equation for the diameter of the dark rings. Okay, for that, what we have is we have this figure. I hope you remember this. We have this figure here. APB is our planar convex lens, which is a part of the circle centered at O. So here OA, OP and OB are the radius, which is generally known as the radius of curvature of the lens, and this XY is representing the glass plate, and at this particular point of contact P, here this particular point of contact P, we have the dark spot, and as we are moving away from this point, we can see that the thickness of the air film is gradually increasing, and we have the maximum thickness of the air film, which is represented as Tn. So corresponding to each thickness of the air film, we have alternating dark and bright rings of varying radius. Okay, so we have a general equation which we derived in the earlier video, which is 2 mu T is equal to n lambda, where mu is refractive index of the air, T is the thickness of the air film, which is not constant, which is varying, and n is the order and lambda is the wavelength. So there is this equation can be written a little more specifically. For example, we have the values of T starting from 0 because there is no air film at this particular point of contact. There is no air film. So T can be start from 0 to T1, T2, etc. Tn. So we can write this equation a little more specifically, that 2 mu Tn, T suffix n is equal to n lambda. Okay, if there is any confusion, I can explain. 2 mu T1 is equal to 1 lambda. 2 mu T2 is equal to 2 lambda. 2 mu T3 is equal to 3 lambda. Similarly, 2 mu Tn is equal to n lambda. That is, corresponding to this varying thickness, we have different orders of the rings. Okay, so that is the general equation, and I am assuming that this is my equation number 1. Okay, what we are going to do, we are going to derive the equation of the general equation for the diameter of the nth dark ring, so that we can write that equation as a general equation, and we can explain every rings. Okay, first ring, second ring, third ring, that we can explain. So now we have a general equation for this particular thing, that is 2 mu Tn is equal to n lambda. Okay, now see, here n is starting from 0, 1, 2, 3, etc. Okay, consider this right angled triangle. Consider this right angled triangle OQA. Okay, this particular angle is 90 degrees, so it is a right angle triangle. So I am considering the right angle triangle OQA. Okay, so from this triangle OA is the hypotenuse, so I can write an equation which is OA square is equal to OQ square plus AQ square. Okay, OA square is equal to OQ square plus AQ square. Okay, so here we have OA. Okay, here we have OA. What is OA? OA is equal to the radius of curvature. Okay, we have QA, we have AQ, which is the maximum radius of the dark ring, nth dark ring. AQ is the nth dark ring's radius. Now we need to find the value of OQ. Okay, we need to find the value of OQ. Okay, for that we know OP is representing the radius of curvature of the lens. Okay, so we can write OP is equal to OQ plus, that is OQ plus QP. Okay, what is QP? QP is representing the maximum thickness of the air film. So we can write the R is equal to OQ plus Tn, and OQ is equal to R minus Tn. Okay, OQ is equal to R minus Tn. Okay, now we have everything. We have OQ is equal to R minus Tn. Okay. Now we are going to substitute all this into this equation. So what we will get? We will get OA square, that is R square is equal to OQ is R minus Tn the whole square plus AQ is Rn square. Okay. So we have R square is equal to R minus Tn the whole square plus Rn square. So you see here we have something which is in the form of A minus B the whole square. What is A minus B the whole square? A minus B the whole square is equal to A square minus 2AB plus B square. Similarly, we can expand this term. Okay. So the equation become R square is equal to R square minus 2RTn plus Tn square plus Rn square. Okay. This is in the form of A minus B square. So we can write R square is equal to R square minus 2RTn plus Tn square plus Rn square. And here, see, there is an R square here and R square here. Okay. This Tn is the maximum thickness of the air film. Okay. Tn is the maximum thickness of air film. As you already saw in the airwedge experiment, the thickness which is a very small value. Okay, you have already calculated which is very small value. So when we are squaring this quantity, it is again very small value. So we can simply ignore this thing. Okay, so we can simply ignore this thing because this is a very small value. So we can write 2R minus 2RTn plus Rn square equal to 0. Okay, because this Tn is a very small value, so squaring it we will get a very small value again. So we can neglect this Tn, this thing we can neglect, and we can rewrite this equation as minus 2RTn plus Rn square, that is 2RTn is equal to Rn square. Okay, 2RTn is equal to Rn square. Okay, and this is the equation number 2. Okay, what was the first equation? The first equation was 2 mu Tn is equal to n lambda. That was the equation number 1. The second equation is 2RTn is equal to Rn square. Okay, so I am going to rewrite this particular equation number 1, that is 2Tn is equal to n lambda divided by mu. Okay, I am taking this mu to this side, so I will get 2Tn is equal to n lambda divided by mu. That is my equation number 3. Okay, now what I am going to do? I am going to substitute this equation number 3 into equation number 2. So I'll get my equation was what? 2RTn is equal to Rn square. Okay, 2RTn is equal to Rn square. So I'm going to substitute this 2Tn is equal to n lambda by mu. So I will get n lambda by mu into R is equal to Rn square. Okay, or I can write Rn lambda divided by mu is equal to Rn square, and Rn, that is the radius of the nth dark ring, Rn is equal to root of Rn lambda divided by mu, and this is the general equation for the radius of the nth dark ring. Okay, this is the general equation for the radius of the nth dark ring. Okay, remember it is dark ring. Okay, Rn is equal to root of Rn lambda divided by mu. I hope you remember all the terms, that is R is the radius of curvature of the lens, N is the order, lambda is the wavelength, and mu is the refractive index. Okay, that is the general equation. So what will be the equation of diameter? If this is the equation, we know that suppose Rn is equal to root of Rn lambda divided by mu. Okay, then the diameter is equal to 2Rn, which is equal to root of 2 into root of Rn lambda divided by mu, or we can write root of 4Rn lambda divided by mu. Okay, that is the general equation for the diameter of the nth dark ring. Okay, diameter of the nth dark ring is equal to root of 4Rn lambda by mu. And here we have air film, right? So this is a general equation for any film. dN is equal to root of 4Rn lambda divided by mu. And here we have air film, right? So in the case of air film, refractive index mu is equal to 1. Therefore, dN is equal to, or we can write dN is equal to root of 4Rn lambda, since mu is equal to 1. And this is the general equation for the diameter of nth dark ring. Okay, thank you.